Top of the morning to you, Mr. Sutton here, bringing you the Pre-Cal Honors 2-3 Extra Practice number 3 solutions on Rational Roots Theorem. For this problem, we're trying to solve for the complex zeros of this polynomial, given that -5 is one of the roots, so they're already giving us that. So we're going to start off by plugging -5 into the polynomial using synthetic division. So writing out my coefficients, I've got 1, 8, 17, and 10. And -5 is going to be my box number. So we bring down the 1 times -5 is -5, plus 8 is 3, times -5 is -15, plus 17 is 2, times -5 is -10, which gives us a remainder of 0, which is what we were hoping for. So I can factor this into x minus -5, or x plus 5, times the quotient here. So that's going to be 1x squared, because it's one exponent lower than we started with, plus 3x plus 2, and that all equals 0. Now this quadratic can actually be factored a little further. Numbers that multiply to 2 and add up to 3, that would be 1 and 2. So I've still got my x plus 5, but I can also factor this quadratic now into x plus 1 and x plus 2. Going through and zeroing out each of these factors now, we've got x equals -5, -1, and -2. For this problem, I'm given that 2 is one of the solutions to this polynomial equation, and I want all the complex zeros. So we know we better be writing x equals 2 as one of our answers, but we need the other ones. I'm going to use synthetic division to plug 2 into this polynomial, and that's going to help me break it down a little bit further. So writing out my coefficients, I've got 5, -18, 19, and -6, and I got a box number of +2. So we bring down that 5 times 2 gives us 10, plus -18 is -8, times 2 is -16, plus 19 gives us 3, times 2 is 6, and then we get 0 when we add those last numbers together. So this means that we can factor our polynomial into x minus 2 times the quotient, which is 5x squared, one exponent lower than we started with, minus 8x plus 3. Now, I might be able to factor this thing. I'm not really sure. I could use quadratic formula. I might be able to factor. You know, I'm going to try factoring this. I'm going to use the AC method to factor this thing. So we've got 5 times 3 giving us an AC value of 15. And now I need numbers that multiply to 15 and add up to -8. That would be -3 and -5. So I can split this -8 up into -3x and -5x, or vice versa. So I've got 5x squared minus 5x minus 3x. Again, that was the -8 here, plus 3. Using grouping on this, I can take a 5x out of the first two terms, which leaves me with x minus 1. And I can take a -3 out of the next two terms, leaving me again with an x minus 1. Now I can factor out the x minus 1, and that will also leave me with a 5x minus 3 next to it. There we go. So putting all of this stuff together now, we have x minus 2, x minus 1, 5x minus 3. I'm just going to go through and zero out each of these factors. So going from left to right, we've got x equals 2, 1, and if I add the 3 and divide by 5, I've got 3/5 for my last answer. For this problem, we're trying to find the complex zeros of this quartic polynomial. Now, they're helping us out a little bit. They told us -3 is one of the answers already. So we can use that with synthetic division to break this down a little bit further. So let me write out my coefficients. We've got 1, 8, 10, -40, and -75. And we'll use -3 as our box number. So bringing down the 1, we've got -3 times that, giving us -3. Plus 8 is going to be 5, times -3 is -15. Plus 10 is -5, times -3 gives us 15. Plus -40 is -25, times -3 gives us 75, and that cancels to give us 0 for our remainder. This means that we're allowed to factor the polynomial into x minus -3, so x plus 3, times this quotient, which is 1x cubed, it's one lower than we started with, plus 5x squared, minus 5x minus 25. Now, I could go a little bit further and look for rational roots and try different things with synthetic division, but this cubic actually, if you look at the ratios here, we have a 1 to 5 ratio for the first two coefficients, and the next two coefficients, -5 and -25, those are also in a 1 to 5 ratio. This tells us that we can use factoring by grouping to factor the rest of this. So I've got my x plus 3, I don't want to forget that, but now grouping the four terms here, I can take an x squared out of my first two terms, leaving me with x plus 5. And now I can take a -5 out of these second two terms, leaving me with x plus 5 there. So I've got my x plus 3, I've got this x plus 5 that I can take out as a common factor, and finally I've got x squared minus 5. Going from left to right and zeroing out each of these, we've got -3, -5, and for x squared minus 5, if I add 5 and square root, I've got plus or minus radical 5 for my last two answers. For this one, we have this quartic polynomial that we're trying to figure out the complex zeros for, and we're given that 5 right here is already one of the roots. So let's go ahead and find the other ones. The first thing I'm going to do right away is I notice all of these have x's in their terms, so I'm going to take an x out of everything, leaving me with x to the third minus 3x squared minus 18x plus 40, all of that equaling 0. So I already know that 0, because of this x here, 0 is going to be one of my answers. They gave me another answer for free. So I'm going to use that 5 with synthetic division on this cubic polynomial part here, and hopefully that can help us break it down a little bit further. So writing out my coefficients just of the x cubed portion here, we've got 1 for the x cubed, minus 3 for the x squared, -18 and 40, and I'll use a box number of 5 for this one. So bringing down that 1, we've got 1 times the 5 there, giving us 5 up here, plus -3 gives us 2, times 5 is 10, plus -18 is -8, times 5 is -40, plus 40 is 0. So I've got the x initially that I took out. I've got now x minus 5, since I got a remainder of 0, I can factor this thing into x minus 5, times my quotient, which is going to be 1x squared, or cubed rather. Now that should be squared. There we go. X squared plus 2x minus 8 equals 0. Now let's see, we've got the x minus 5, and now we can actually factor the rest of this a little bit here. Numbers that multiply to -8 and add up to 2, that would be x plus 2, or actually x minus 2 and x plus 4. It's got to add up to a positive there. So going from left to right, just zeroing these factors out, we've got x equals 0, 5, 2, and -4.